Now it turns out that logistic regression, on the other hand, can do what we just did. Now we will go through what these models mean and how to interpret them. I just want you to get the flavor of this algorithm before we dig down deep on what it does. So instead of linear regression, we import logistic regression this time. From scikit-learn. As usual, the scikit-learn API remains the same, so we still have to specify our X by specifying the features that we want to use as part of our X's. The Y will be household, and if we fit that and predict, then we get our predictions corresponding to logistic regression. Now if we plot it again, it remains the same. So instead of using numpy.where over a linear regression model and then hand coding that threshold, logistic regression was able to go through all those steps automatically for us to give us a classification algorithm out of the box. Now think of it. Instead of the specific class, what if we wanted the probability of being that class? So what I'm trying to say is, you're trying to decide whether you want to take an umbrella out for work today, and you want to make that decision based on some data that you're looking at, let's say the rain patterns, the weather, the temperature, humidity, etc. Now, the decision will be either you take an umbrella or you don't take an umbrella. But for mathematical precision, you want to know what is the probability that it will rain. So if you say that the probability of raining today is 0.8, you say that there's a high probability that it will rain, and so you'll take your umbrella out. So instead of zeroing down on the decision, you want to take a step back and calculate the probability that that event will occur. So we basically want to understand how confident we can be given that we do a prediction. So instead of using the .predict of scikit-learn, we instead use the predict probability or predict_prob A function, and we pull out the probability of ones. Notice that predict_prob A, and you can see this for yourself once you get your hands on this notebook, actually outputs two sets of probabilities, since we are dealing with a binary variable, the probability of being a 0 and the probability of being a 1. We are doing some slicing on that output to grab the probability of ones only. And now if we plot the predicted probabilities, this is what it will look like. And if we want to see some probabilities, we need to run this. The first column indicates the predicted probability of class 0, and the second column indicates the predicted probability of class 1. Now this is the exact same reason, notice, why we had to slice our data here to get the first column out and just select the second column so that we have all the probabilities of being 1. So in this case, if AL is equal to 1, our logistic regression model is telling us that the probability of being a household class type is very low. It's 0.02. And for the second case, it went up to 0.65, and for the third case, it went up further to 0.99.